The engine incorporates several advanced technology features. The pylon is attached to the lower surface of the wing and supports the engine by two mounts. The engine size and weight are displayed on the screen. The nacelle provides protection for engine and accessories and also ensures airflow around the engine during its operation. On the fan cowl, left side, an oil access door is provided for engine oil servicing. On the right side fan cowl, a starter valve access door is provided for manual override operation. The inlet cowl anti-icing duct is accessible via a panel.
The CFM56, made of 4 primary modules, permits easy replacement at modular maintenance level. The low-pressure or N1 rotor, supported by 3 bearings, consists of a fan and a 4-stage compressor driven by 5-stage turbine. The high-pressure or N2 rotor, supported by 1 double bearing on the front and 1 roller bearing on the rear, consists of a 9-stage compressor driven by a single-stage turbine. The combustion chamber is of the annular type. It has ports for 20 fuel nozzles and 2 igniter plugs. The accessory gearbox is mounted on the fan casing lower part. It is driven by the HP rotor via a transfer gearbox. The accessory gearbox is equipped with mounting pads to drive the accessories shown on the screen. Here are the main aerodynamic stations. Several ports are provided on the engine for borescope inspection. The engine control is built around a full authority digital engine control system, which serves as an interface between the aircraft and the engine control and monitoring components. The FADEC provides the regulation and scheduling of the engine systems to control the thrust and optimize engine operation. The FADEC system is self-powered by a dedicated permanent magnet alternator when N2 is above 15%, and is powered by the aircraft for starting, as a backup, and for testing with engine not running.
The fuel coming from the aircraft tanks through the LP valve is driven by the low-pressure stage of the main pump. It is heated by the main oil or fuel heat exchanger, filtered, and then pressurized in the high-pressure stage of the main pump before entering the hydromechanical unit. The fuel from the main pump passes through a fuel metering valve and an HP fuel pressurizing and shut-off valve included in the hydromechanical unit. The fuel then goes through the flow meter and the burner staging valve to the nozzles. The fuel metering valve is controlled by the ECU to obtain the desired N1, selected either by the thrust lever or the auto thrust system. The burner staging valve is electrically controlled and hydraulically operated. It closes one manifold at low fuel flow to provide a better nozzle spray. When the engine master control is set to off, the LP and HP fuel shutoff valves are closed, and a hydraulic shutoff signal is sent from the hydromechanical unit to the fuel return valve. Filtered fuel is delivered from a self-cleaning wash filter through a servo fuel heater to the servo valves of the hydromechanical unit, HMU. Part of this fuel is also delivered to the fuel return valve as muscle pressure. In the hydromechanical unit, the servo valves are hydraulically driven by torque motors controlled by the ECU to provide the operation of rotor active clearance control, low-pressure turbine active clearance control, variable stator vanes, high-pressure turbine clearance control, burner staging valve, variable bleed valves, and fuel metering valve. The fuel bypassed from the HMU is used to cool the IDG oil. The fuel then returns to the fuel pump interstage and recirculates through the system. If the recirculating fuel gets too hot, the ECU controls the fuel return valve to allow some hot fuel to return to the aircraft tanks. A mixing chamber located inside the fuel return valve mixes cold fuel from LP pump with the hot return fuel to reduce thermal stresses. The pressurizing valve ensures that there is always pressure in the return line to prevent fuel from vaporizing. The fuel return valve is electrically controlled by the ECU and hydraulically operated by the servo fuel. It receives a hydraulic shutoff signal at engine shutdown and is closed by a spring.